A rectangular pool measuring 6 meters by 20 meters is to have a walkway installed around it with a width of x meters, as shown in the diagram below. Together, the walkway and the pool have an area of 240 square meters. Write an equation that could be used to find x, the width of the walkway. If I'm looking for x, knowing the area, I know that the area is length times width. So I need to write an expression for the length in terms of x and the width in terms of x. If I'm talking about my length and width, my length, we could say for this rectangle, goes up and down. So if I look at all of my numbers or variables that go in that up and down direction, we have an x, 6 meters, and another x. So therefore I could say that my length, if I add up all of my pieces, would be x plus 6 plus x. So we have x plus the 6 plus the x that make up our entire length of the rectangle. If we combine like terms, that means that our length is equal to 2x plus 6. I also need a width now. So for my width, the width of our rectangle, we can say goes side to side, and that makes up our width. So that was our width and our length. Now I need to look for all the pieces that go side to side that make up my width. So we have an x, 20 meters, and another x. If we add up all the pieces that go side to side on our rectangle, we have an x plus a 20 plus an x. So it was x plus 20 plus x that make up our entire width of the rectangle. Combining like terms, that means the width of our rectangle is 2x plus 20. Since area is length times width, as we said, I'm going to take my length and multiply it by my width and make it equal to the total area, which was 240. So our equation is 2x plus 6 times 2x plus 20 equals 240. Describe how your equation models the situation. The problem told us that the total area, including the walkway and the pool, was 240 meters. And we know that the area of a rectangle is length times width. Therefore, in order to write our equation, we needed the length and the width, and we also needed to include the x from our walkway. So to describe how our equation models the situation, we can say that the area is length times width, including the walkway around the garden. Determine and state the width of the walkway in meters. In order to determine the width of the walkway, we need to figure out what x is in our equation. So our equation is 2x plus 6 times 2x plus 20 equals 240. The first thing we need to do when solving this equation is we need to get rid of our parentheses. As a result, we're going to have to double distribute. So we're going to take our 2x and multiply it by the 2x plus 20. And then we have to take our 6 and also multiply it by the 2x plus 20. So that's 2x times 2x plus 20 plus 6 times 2x plus 20 equals 240. Now we have to distribute again to get rid of those parentheses. So we're going to do 2x times 2x, 2x times 20, 6 times 2x, and 6 times 20. Giving us 4x squared plus 40x plus 12x plus 120 equals 240. So the 2x times 2x gave us our 4x squared. Our 2x times 20 gave us the 40x. Our 6 times 2x gave us the 12x. And our 6 times 20 gave us the 120. Combining like terms so that we can simplify our equation, give us 4x squared plus 52x plus 120 equals 240. Because of the x squared term and the x, we have a quadratic equation in which we have to make it equal to 0 so that we can factor and solve it. As a result, in order to make it equal to 0, we have to subtract the 240 on both sides. After subtracting the 240 on both sides, we're left with 4x squared plus 52x minus 120 equals 0. Now that our equation is equal to 0, we can factor to solve for x. The number one rule in factoring is to always look for the greatest common factor first. So between 4x squared, 52x, and negative 120, our GCF is going to be 4. Dividing each of my terms by 4, I have 4 times x squared plus 13x minus 30 equals 0. In order to factor my trinomial, I'm going to need two numbers that multiply to negative 30 and subtract to 13. So I want to come up with numbers that multiply to 30 and subtract to 13. Those two numbers are 15 times 2. So I'm going to take the x squared and bring it down. I'm going to bring down the minus 30, and I'm going to rewrite that middle as 15x minus 2x, giving me x squared plus 15x minus 2x minus 30 equals 0. I still have this 4, but I'm going to hold off for a minute until I finish factoring my trinomial. Now that I have 4 terms, I can use factor by grouping, which means I'm going to split it in half and find the GCF of each side. The GCF between x squared and 15x is x, and when I divide both terms by x, I'm left with x times x plus 15. On the right side, I need to find the GCF between negative 2x and negative 30. And my GCF for those are negative 2. So when I divide both terms by negative 2, I'm left with negative 2 times x plus 15. Now that we've factored both the left and right side, we want to factor the GCF out of our entire problem. So the GCF between x times x plus 15 and negative 2 times x plus 15 is the x plus 15 that they both share. So we're going to factor out the x plus 15, and we're left with the x minus 2. So that our factors are x plus 15, x minus 2, and the 4 that we pulled out in the beginning, we have to make sure that we carry down with it. Now that my trinomial is completely factored, I can set each piece equal to 0. So 4 is equal to 0, x plus 15 is equal to 0, and x minus 2 is equal to 0. On the left, 4 cannot equal 0, so we're going to reject that. In the middle, in order to get x by itself, we need to subtract 15 on both sides, leaving us with x equals negative 15. However, we know that negative 15 cannot be a length or width because measurements cannot be negative, so we're going to reject that one again. And our last one, x minus 2 equals 0, can be solved by adding 2 to both sides, leaving us with x equals 2. The problem asks us to find the width of the walkway. Our width was x, and therefore we know that the answer to our question is that our width is equal to 2.